welcome to today's video. Welcome to my YouTube channel. So this is my first video. I'm going to create a very simple basic tutorial of how to create a WebRTC based video calling app for peer-to-peer video calls. So you can have your own video calling app without any external service like Google Meet. You can have a very secure connection with your peers and you can have your own app. We're going to build this entirely from scratch. There are many libraries available to make it easier for you, but in this tutorial we're going to make it entirely from scratch without using any of these external libraries. So let's dive into it. Before we get started, this is a guide that I've followed. It's by Alex Liu. So shout out to Alex for creating this wonderful guide. I'm going to link this in the description so you can look at it when you need. A little about WebRTC. What WebRTC is, it's a peer-to-peer communication framework that allows you to have a peer-to-peer connection without the need of a of an intermediary server. There is a signaling server that we'll get into later on, but WebRTC is open source and it allows you to have video and audio based peer-to-peer connections. There are a bunch of things that comes into play with WebRTC, but this is a very basic tutorial. I'm not going to get into all the nitty-gritties of it. What you should understand is that WebRTC works over the internet, and you can have a P2P connection with other users. What that means is your connection to another user is directly through your computers. There's no server involved in between, and you do not connect through a third party or any other server. There are a bunch of other concepts that you should get into. I'll link this Medium article in the description. You should go over it, but in a more advanced version I'll also cover it myself. Alright, so we're going to use Next.js for the front end, and we're going to use Node.js plus Express for the back end, the signaling server. Again, we'll get into what the signaling server is very soon. So without further ado, let's create a new Next app. And everything that I do, I'm going to try and do it by looking at resources online. So even while you are doing it on your own, you know how to go on about looking for things when you get stuck. Alright, so I'm on the Next.js official documentation. I'm going to create a Next app. It's okay if you don't know how Next.js works, as long as you know JavaScript and React. It's fairly basic, fairly simple. There's not a lot of things to it. You can watch a quick tutorial and let me know in the comments if you want me to include a tutorial for Next.js as well in the future. So I'm going to call it WebRTC video chat. No, I'm just going to select all the default options, and it will install all the libraries for me. Now, the reason we are not using Create React App and using Next.js is because some of you might know that Create React App is a legacy framework, legacy method to build React apps. Next.js is what is recommended by React in the official React documentation. So the app is installed. You can see I have a new app and I did a typo. Instead of chat, I just have cha, but I think that's going to be okay. So let's get into that folder and open it in VS Code. Again, while this is a very basic tutorial for WebRTC, it does expect you to know some basic coding, programming in JavaScript. If you do not, and if you also want a very basic videos to get started with JavaScript, do comment below and I'll create some videos for that as well. So when you build a Next.js app, this is what you get. You have a page.js, and if you go to package.json, you'll see there is a dev script, there's a build, and there's a start, and there's lint. I'm going to run the dev script. So you can run yarn dev, and you'll see the server is running on localhost 3000. I'll go there. I already have that open, and you'll see the page will come up in a while. Alright, so you can see that I have a Next.js app running. This is the boilerplate code that you get when you install Next.js. Now I'm going to get rid of all of this So we are using Tailwind CSS again. That is a library that you use to quickly build better looking web pages using some ready-made classes that are available. Uh, it's okay if you don't know about Tailwind CSS either. It's fairly simple, and we'll get into the documentation for that as well for a little bit. Now, what I want to do is I want to first create a page. So before that, let's save this, and you'll see that all of that content goes away. Now you have a blank page to work with. Now I'm going to create a simple form where I'm going to ask for the name of the channel that the user wants to create and their username. So let's get into it. So I'm going to give this div some classes. Now this is Tailwind CSS. So if you don't know, I'll link the documentation as well in the description, and you can follow that. So I'm going to create a flex box with column. I'm going to give it some 100 width, and then I'm going to justify center, and then items I'll align center as well, and then I'm going to give some margin auto and then some padding, and I'm going to give it a screen height. If you save, you'll not see any difference, but now I'll just add a simple text here. I'm going to add a p tag and say welcome to your own video calling app built from scratch. Right, let's save it. You see that message right here. Now you're seeing it at the center because of all these classes that we added. Now I'm going to create another div, and I need a label. Say enter your channel name, and I'm going to make an input, and this is, so we're going to use React, as you know. So let's import use state and create a state variable for our input. Again, I expect some basics to be known for React and JavaScript. If you do not, you will first need to go over some videos or some documentation to learn how to use React. But if you do, then this is all going to be fairly straightforward. So I'm going to create a controlled input, which means I'll give the value channel name, and then on change I'm going to set the channel name. Fairly basic for anyone who knows React. I'm going to give it an ID to channel name, and I'm going to give this an HTML for tag channel name. So yep, right. So if you use React like the old methods, you wouldn't face this issue. But with Next.js, now Next is a full stack framework, which means we can build backend as well as front end applications. And use state is only available on the front end, like the client side applications. So you need to add this at the top of your page if you want it to be a client side. If you want this code to run on the client side, otherwise by default Next.js assumes everything's for the server side. So now you see we have a label and an input field, and if I click on the label, I see the input field highlighted, so this thing works. Now I'm going to make it look a little better. I'm going to make this a flex as well and give it column, and I'm going to give it some margin. Yeah, this looks slightly better. Now I'm going to use, so what I did is search for Tailwind CSS input. Let me come here. This is some example that I'm just going to use. I'm not going to spend a lot of time styling it, but I'm just going to use these classes because I like the way this looks. So here's for the label. As you can see, the label looks slightly better, I guess. And then I'm going to copy for the input as well. Oops. Right. So as you can see, we have slightly better looking input field, and I'm going to give it a placeholder uh, channel name, right? And then I want to duplicate this block, and I'm going to create one for username. Just say enter your name. Yeah, and then I need one more state variable. Right, and I'm just going to use this. Alright, so we have a very simple looking form. I know it doesn't look all that great, but it's not the idea. The idea behind this is to just build a very simple, very quick, basic application that uses WebRTC end to end, and you can make a video calling app for yourself. Okay. Now, I'm going to add a button as well. Again, I already have something for button right here. The same Flowbyte website which uses Tailwind CSS. You can get here the same way we did for the input field. I'm going to copy this button and I'm going to call this class name. I'm going to say call. Once I save this, you can see that we have this form ready. Alright, I'm going to reduce those margins a little bit because they look very wide apart. Alright, so we have our form ready. Alright, so now that we have our form ready, let's get into the actual WebRTC stuff. Now, on the click of this button, I'm going to call a function. Let's define that function here. Constant on call click, and I'm going to call that function here. Now what we want to do is simply redirect the user to a different page where we'll have the actual video stream. So to do that, what we need is something called use router, which is provided by Next navigation. Going to create a router object using this. I'm going to say router dot push to this route called call. And now I also want to pass this username and the channel name as a query parameter. So to do that, I'm going to create some query parameters using URL search params, and I'm going to use the channel name and the username, and then to string, and then just pass the query here. Yep. Alright, so let's see how this works now. I'm coming back to this. Let's enter something, and then click call. As you can see, we are redirected to this page call, and then we have these parameters that we entered in the previous page, but this page does not exist, and this is the default view that you get when a page is missing. So now let's go ahead and create that. To do that, it's fairly simple with Next.js routing. You just create a folder called call, and then within that you have a file called page.js. Now let's export default function. Right, let's try again. You can see we are being redirected to this page. You can see the message hello, and this time it's all undefined because I didn't enter anything. Alright, so now let's get into the actual stuff, what we really need for the WebRTC connection Now, I talked about a signaling server. So how this works is that there is a user A wants to get on a call, and they would send their details slash data. Now they want to send this to user B, right? Now how do do that? Because user A does not know how to connect to user B, which is where there is a signaling server. So what it does, it provides a handshake between user A and user B, so they connect to each other, and then the rest of the connection is directly between user A and user B. So that signaling server will receive some data from user A, basic details like that which is required for a WebRTC connection, and then it will publish it to other users that are online. And if user B wants to get on a call with user A, user B will receive that information and then connect to user A directly. That is very high level, but if once we get into it, it will make a lot more sense. So I'm going to just format it a little bit. All right. Now we're going to call this again use client, because this is a client side page. Now we're going to use WebSocket for this signaling server, and to do that, let's first start by defining a WebSocket, a variable, a constant for the WebSocket URL. So this would be ws localhost. I'm going to use port 8090 /ws. This is we don't have that WebSocket server running yet, which will build just in a minute. But what do we want to do now is when this component bounds, so we're going to use useEffect for it, and here we're going to connect to our WebSocket server. So we're going to create an object web client, and this would be a new WebSocket. I'm going to use this URL and so I'm going to open the connection. So this will automatically open the connection, and then when the connection opens up, I'm going to have a callback. Just let's log ws opened. Now I need to store this WebSocket connection somewhere, for which I'm going to use a ref. If you don't know what refs are, please go to the React documentation, or if you'd like me to create a detailed video of these concepts in React, please comment down below and I'll do that in the future. So I'm going to set up within this on open. Once the connection is open, I'm going to set the ref to this WebSocket client. That is it for now. Now let's go back and create the WebSocket server. So this is where the next server is running, next app is running. I'm going to go back and I'm going to create a new app. Let's call it signaling server. Now I'm going to initialize this as an npm app. If I pass -y, then it will not ask me any questions and it will use all the default settings. Alright, so let's open this in VS Code again. Alright, so as you can see, we do not have any packages installed, so let's go ahead and install some packages. We're going to need WS, which is the WebSocket client. So I'm going to add yarn. I'm going to use yarn and add this package called WS, and I'm also going to use Express. I think we'll need that. And I'm going to use nodemon to watch for changes and then have a debugging server, a dev server running. Alright, so I've installed these dependencies here. Now let's create an index.js file. Let's create an app socket server, an express server first. Right. Then I'm going to create some ports, say 4000. So I'm going to use 8090. That is what we used here. um, let's first start the express server. Right. Let's see. Let's run this. Let's use VS Code's terminal. Run this. I'm going to run yarn dev. So let's first create that script here. Let's create a dev script. I'm going to use nodemon. Right. So nodemon watches for changes. Every time I make a change, I don't need to restart my server. It automatically does it for me. Right. Let's go to the browser and go to localhost 4000. Alright, we're able to connect, which means we don't have any routes, but we're able to connect, so it means the server is up and running. Alright, now we're going to create the WebSocket server. So for that I'm going to create a new file, wss.js. As you can see, it automatically refreshed. So now this is going to be our signaling server. We're going to need a bunch of functions. So first let's import WebSocket. And let's create a function called init, which will take a port, and this will initialize our WebSocket server. So WebSocket server, new WebSocket dot server, and then I'm going to pass the port. Right, and then I'm going to define a bunch of callbacks. So on connection, I want to set up some more callbacks. Let's log a client has been connected, just for debugging. Right. I'm going to say socket.on, and then in case of an error, I'm just going to log it to the console using console.error. Let's create another callback for message. So whenever the socket server receives a message, I'm going to call this function called onMessage, and we'll pass the WebSocket server, the socket object, and the message. Now this onMessage is not defined yet, so we'll define it in a minute. And then finally we want a listener for close as well. So message, again on close is not defined, we'll define it in a second. Right, so let's define the on message function. Let's define the on close as well. So on close is going to be straightforward. We'll come to that. Now on message, we're going to need a bunch of different messages. We'll need a join message when a user joins the channel. We'll need one for quit when someone quits the channel. We'll need one for send answer and one send offer channel as well. So these are terms used in WebRTC. The clients send an offer to connect, the other client receives the offer and then sends an answer back, and then there is some more data being shared called which is called the ICE candidate. So we're going to need an ICE send ICE candidate event as well. So let's go ahead and start defining join and quit. Now what I'm going to do, I'm going to keep it very simple. I'm going to create a channels object which will keep track of all the channels and which users are in which channel. Okay. Now on message. Now we actually need to accept a bunch of fields for the message. So and this would be a JSON string. So let's first have a parsed message which will get by JSON.parse. Now from the parse message I want to extract a bunch of fields. So every time we would expect a bunch of fields to be sent. First would be the type, which is the event type that we've listed down below, and then there's a body. And from the body, we could have more fields. We should at least have a channel name and a user name for the body. And we would have more data, but from in the body, but channel name and username is something we'll always have. Alright, let's move this up. Alright, now I want to use switch case. Now first we'll start with join. Now this is when the user joins the channel. We'll have the channel name and the user name, and we need to add this user to this channels object. So let's see if the channels object has this channel already. If not, then let's add that channel. Right. So by this point we would always have a channel name within this channels object, and at worst it would be an empty object. So now we can add the user to this channel name. And the value for this, I'm going to use the socket object. So this is the socket connection that will receive for this particular connection, or this from this particular user or the client. Okay. And now what I want to do is simply get all the user names that are within the channel. Object.case channels channel name, and then I'm going to send it through the socket. I'm going to call this a joined event, and I'm going to pass the usernames. Right. So we don't have the send function, so let's go ahead and create one. This will help us send messages on our WebSocket connection. So again, this receives a WebSocket client. The type of the message, this is this one. Now this is something that the clients will consume. A server has these events, but will create other events for which the types would be defined here, and these would be something that our clients would listen on. Then we'll have a body. We will use the WS client, the WebSocket client, to send a stringified body and the type object. Alright, so we have this. Now let's go ahead and define the next case, which is going to be quit. Now for quit, it's again straightforward. If the channel exists, I am going to remove that user ID, username, and then set it to null. We were setting it to the socket here. In this case, we'll set it to null, and we'll first check if that channel name actually exists. So if that username doesn't exist, it's okay, it will just set it to null, but the channel name should exist, otherwise we'll see some errors. Now again, I'm just going to copy this part here, And if there are no more users in this channel, so if not usernames dot length, I'm going to delete this channel altogether. Right, just a bit of cleanup. So we do need to add break everywhere. Alright, so we have the join and quit done. Now the rest of these we can actually go ahead and implement them right here because they're going to be very similar, but only because there's nothing really specific about any of these. We're just going to get some more data which will again pass on to the clients. So let's do send offer. I'm going to duplicate this block, call it send offer. Now the only difference is in this case the body would also have an SDP object. What is SDP? You can go to this blog. Alex has written a bit about SDP as well, or let's search WebRTC SDP. So this is a session description protocol. This is basically an object that allows you to share some information about yourself as a client, so your peers can use it to connect to you. Okay, so this is a send offer. We're going to get the SDP object. Now let's get all the usernames, and for every username I'm going to send every user a message saying offer SDP received, and send this session description protocol so that all the users that are connected are on this particular channel will receive a message saying that there's a new user who is connected and has sent an offer to connect. Now to do that, the WS client will come from the channels object. Alright, now the only thing we need to do is we want to send this message to everyone but the same user itself. So when the user joins, we will add it to the channels object, but when user A sends an offer and there's B and C users in it, we want to send A's offer to B and C but not back to A itself, right? So we can simply check if user name is not equal to the, right, 1 second, I think this is going to mess up, so I'm going to say name. So name is not equal to username. That is when you want to send the data to everyone else. So name is one of the users that is in the channel, and this username object is coming in the body. Okay, so we are sending the data to everyone except for that same user. Really straightforward. Let's quickly do it for the other two events as well. Just send answer. Now send answer receives something similar. It does something similar like send offer, but the only thing is this event is going to change. Answer SDP received, but everything else remains the same. In this case, we are receiving an answer and we are telling everyone else that that answer has been received and creating this event. Finally, send ICE candidate, and in this case we'll receive a candidate object, and we're going to change this event ICE candidate received, send the candidate object. That is it. This is what we need for the socket server really. Let's go ahead and quickly implement the close on close event. So let's add a console log here just for debugging. And what I want to do now is delete every user within every channel. So delete the given user in every channel. So let's say object.keys channels for each. Now this is the channel name. Now for every user within that channel, now I want to remove the user from every channel where it's the same message, right? So the same socket. So channels.cname .uid right. So when a user quits, when a user leaves the session, what do we want to do? We want to remove that user, which is the socket object, from all the channels, so that the user is not showing as online anymore. Right, I think this is all we need for our WebSocket server. Now let's just export this function in it and go back to our index, import the WebSocket server, and wss.init socket port. Right, let's just add a message here. If we go back, you see the message WebSocket server initiated. So this is all we need for our WebSocket server. If it's a little bit hard to keep up when we use these functions, these events, we can go back and rewatch this part, so you know exactly what we did. Now coming back to our client, now let's see if we're able to connect to the server. If I go back here, I'm going to enter a channel, cd. Let's just refresh it once. ABCD 1 2 3 4. So if you see WS open is what we see, and this is coming from here. And let's see, you'd also see a client has been connected. Awesome, we are able to establish a connection with our WebSocket server from our front-end application. Now, like we did on open, I also want to implement on close. In this case, let's just add a console for now, but let's also add another event, another listener for on message. So this is where we will handle all these events that we were creating from here, these ones. This is where we'll handle all of that. So again, we'll get a JSON object, so let's parse it. And we have a type and a body, in the pass message, because that is what we are passing here. So let's have a switch case for the type. So we have joined. Let's just add empty cases for now. So we need one for join, one for offer SDP received, answer SDP received, and ICE candidate received. So let's just do that very quickly. Right. So joined is something, let's when a user joins, we're letting everyone else know who joined. So let's quickly implement this and see what happens. So let's add a console log. Alright, let's see. So I'm going to start again. Let's look at this error in a while. Alright. Should see a message here. I'm also going to do this in incognito again. So we can simulate multiple users being connected. Right, there's something up. We don't see this joined message. Let's see. Because we are first not invoking this joined event. We've missed that. Let's do that. So when we connect to the WebSocket server, let's set up our device. When I say setup, what we need to do is we need to enable the camera, the microphone permissions, etc. So that we can start with the P2P connection. Alright, so we need to have the setup function created. In here, let's say, okay, so we're going to use the navigator API to get user media. Now this will allow us to get the video and audio streams from the user, from the user's device. Now we would create two video players in a minute. Let's use them. Let's try to set them up though. So we're going to use document got get element by ID. And we're going to set the source object to the stream, which is right here. And I'm going to create a global variable, local stream, which would be used across different functions. We'll see in a while. We'll set it to the stream, and then next, finally, once we have the setup done, what we want to do is we want to call the we want to create an event, the join event on the WebSocket client. So let us do that. So we have the WebSocket client in the ref. You're going to use a send method, again a stringified object, and we need the type, which is join, and then the body. In the body for join, as you know, we need the channel name and the username, right? So the channel name and the username. Now if you see, the channel name and the username is available in the query parameters. So in Next, how you can get that is using a search params object. So let's import the hook from Next/navigation. It's called use search params. And let's go ahead and use it. Right. And now we can get the channel name and the username from the query parameters. Alright. Now let's try this out. So failed to execute. Okay. Needs 3 arguments but only 2 are present. Let's see. Okay, I guess we are missing the error argument here. So I'm just going to log the error. Alright. As you can see, it's asking for camera permissions, etc. Which it already has. Okay. So we are seeing this error source object of undefined because we are trying to set it for the local player, which is supposed to be a DOM element, but we have not created that. So we'll do that in a while, but before that let's check if our connection is working. So let's add a console log over here so we can do a quick debug check. Right, A B C D 1 2 3 4. Right. So actually okay, we're doing this after setting, so it's failing. So let's just go ahead and create the video player first. So I'm going to first create this div. I'm going to use the same values, same classes. Then I'm going to create another div which will be a flex row, and here I'm going to create a video player. Now I'm going to add an ID. I'm going to call it the local player. I'm going to set autoplay to true. I'm going to give it some basic styling. I'm going to give it width, say 640, and height 480. Right. I'm going to create this one more time. And I'm going to call it the peer player. This is where the actual stream for the peer, your friend video will be played. So if I go ahead and save this, yep, as you can see, you're able to see me now, and you can see that there is a user who's joined the channel. If I go back here, I try to join it from this other browser, and you'll see that this is the stream that I'm seeing now, and I can see that there are 2 users connected to this WebRTC, this WebSocket connection. So I'm going to comment this part out for now, so that we don't keep seeing the player over and over again. We'll go ahead and implement the rest of the functionality now though. Alright, so now what we want to do is, after sending this event, we want to set up the WebRTC connection and actually send the WebRTC related data to the clients. So let's call another function. We'll call it setup peer connection, and we'll call it from here. Now here we want to create so I'm going to create another global variable called local peer connection. And here we're going to create a new RTC peer connection object. I'm going to pass an empty array here. This is where you can pass some turn and turn server configurations. We're going to skip it for now, but maybe in the advanced version of this video we'll have that. And then I need to pass some constraints, so I'm going to call it PC constraints. Let's define that here. This is again something you can find it in the documentation easily. Now we need to pass a DTLS SRTP key agreement value set to true. This is for security reasons. This will configure how the WebRTC connections will connect to each other. The peers will connect to each other. This is a more secure way, so we're just going to set it to true. So we've created this local peer connection object. Now we need to define a bunch of functions again. So local peer connection has a function called onIceCandidate. Now in this case we want to call this function local ice, so got local ice candidate offer. Let's go ahead and define this. So this is the function that would be called on this event when an ice candidate has been created on this peer connection, local peer connection, and this will receive an event. Now to check if this event does not have a candidate, then we need to create an offer. Now this is where we'll create the offer for sending to all these other users. So we do that like this. So the local peer connection will have an object called local description. This is the offer, and we're going to use a WebSocket client to send a message to the rest of the clients on the WebSocket connection. So let's first create a function that we can reuse for sending messages. We're going to use WebSocket ref that we defined above. We're going to send a message in a JSON stringified manner. Right, let's go ahead and use it here. I'm going to use send offer, which is this event. And we're going to pass the channel name, which we'll get from the search params. We need the username, so username, and then finally we need the SDP object, which is this offer. If you see, we have an SDP object that we send to the other users connected on this WebSocket connection. So this is what we're doing here. Next, on the peer connection again, we have an event called onAdd stream, for which we'll call this function got remote stream. Let's go ahead and define it. Now here I'm going to take the remote player this time. It's this one right here, and here I'm going to set the remote player source object to the stream that we get from the peer-to-peer connection. Now this will receive an event here. Alright. Now finally we need to add another listener, which is an add stream. Okay, so we need to add a stream, it's not a listener. And this is the local stream that we will add. Finally, we're going to create an offer. When this is asynchronous, so when we have an offer, we need to call this local description function, called local description. Alright, so let's go ahead and define this. And here this is going to set the local peer connections local description to offer. Let's make this a little cleaner. Alright, so now as you can see what we're doing, we're creating a new peer connection. Now this actually the sequence of this should be like this. So anytime when we create the local peer connection, we create an offer and we set it as the local description, and then there's an add stream. So we are adding a stream which is the local stream to the local peer connection. This is your stream that you get when you set it up, right? This is the stream. Let's just uncomment it before we forget again. Then for the on add stream event, we're going to, so when there is a new stream being added, we're going to set it to the peer player. And then finally when an ICE candidate is created, which will happen after you create the offer. So as you see here, we're using the local description, right, which we are setting right here. So this is why this goes at the end. We're going to create the local ICE candidate offer and we'll send it to the other users in the connection. So this is all we need to join a connection and create a new offer. Now let's set, so when the offer is created, we are again answering back with this event offer STP created received. So let's go ahead and set this event up next. So now let's start by implementing this event offer SDP received, because this is the event that will be created from here when a client sends an offer. So we're going to accept the offer which is coming from the body. So we would get parsed message dot body or just body, and let's create a function called onAnswer and pass this offer. So let's define this function now. And we're calling it onAnswer because the client created an offer in response of which they received this body. So this is the event that was triggered, send offer, which resulted into this event. So this was actually the answer that you're getting back. So that is why we are calling it onAnswer. Now in this function we're going to do something very similar to what we did right here during setup peer connection. So let's go ahead and copy this here. Next we're going to say local peer connection dot on ICE candidate, and here we're going to create a new function got local ICE candidate answer. Now let's define this function. So this will receive an event same as this function right here. So we're going to say if not event.candidate, there's no event.candidate, then we get the answer from the local peer connection dot local description, and we send the message to the WebSocket, send answer. And here again the channel name and everything is going to be the same. Next, we're going to add another event on add stream, and this will again be got remote stream, which is this function right here. Okay, there is a typo here, so let's fix that. It's document. Next, we're going to add a stream, and this would be our local stream. We will also set the remote description. This remote description is of the remote user, that is your peer. And then finally we're going to create an answer, and this is an async function, so we get an answer, and we call this new function got answer description, and pass the answer. Let's go ahead and define that function. And here we're simply going to set the local description as the answer. Let's go ahead and save it. Now we're going to send answer here, so this is the event that we're going to receive, and as part of which we're going to create another event, answer SDP received. So let's implement that now. Now this is going to be very simple. We are going to call got remote description function, and we're going to pass the body, because that is what we are getting right here. So let's implement it. Here we are simply going to set the remote description as the answer, and we're going to add an event on add stream and set it to got remote stream. Let's save it. Let's go back to our browser, and we have this channel name ABCD and username 1234. Now I'm going to create another session from an incognito tab to simulate a different device. I'm going to go to localhost 3000. I'm going to join the same channel but with a different username. So let's see. So this is my feed. Okay. So I see 2 users, but I do not see the second stream. Let's see what error is this. Okay, this is for the input. Okay, I don't see any error. Let's try to debug. Okay, I don't see this function being called, so I guess this event is not being created. Let's try to add a console log here. So this is offer STP received, which is from here. Let's see if we're getting a console log here. So as soon as the server restarts, WebSocket connection gets slow, so we need to refresh the browser as well. Okay, so I don't see a send offer event being triggered either. Let's go back here. Let's see if this is working. So this is being called from here, set up peer connection. Okay, let's see if this function is being called first. Yes, this function is being called. So this is the function that is not executing. Maybe let's try and add this console log here. Okay, so we're never getting this event here. Okay, I see why. Because while I was showing you how this will exactly flow, I actually misarranged these listeners. So we do need to define the listeners first, like this. So we need to define the listener for on ice candidate before we create an offer, because when this offer is created, that is when an ice candidate might get ready, and then we call this function. So we are actually calling this first, and when this is executing, this event has not been set up, this listener has not been set up, so we're not getting this. So this should work. Let's try and check it out. Let's save and go back to the browser. Alright, so I do see event being printed here, but I do see an error here. So this is on 72. Okay, this has to be answer. Alright, let's save it and let's retry. Alright, awesome. I do see 2 feeds now. The second one, this one is from my other computer. So if you see, I'm looking here. If I say hi, I see both the feeds. So seems like our simple web app for P2P video calling is working perfectly. Let's just go back here and fix it so it's in a row and not a column. Let's see. Yep. Let's refresh once. Yeah, I do see 2 feeds now side by side. This is the user 1 and this is the user 2. So this is all you need to set up your own WebRTC based P2P video calling app. As you can see, we're not using any libraries here. Anything that is maintained by third-party providers to support video calling. So this is fully secure. This is something that you control, so you can have a very private chat room for you and your friends, your partners, to have a private conversation without the need to worry about privacy. Now, of course, this is something that is very basic, very simply set up for you to try out WebRTC and see how it works. To actually deploy this as an app, it's going to take a little more work. So if you do want me to build an advanced version of this video where we actually go ahead and deploy this on the cloud, so you can share your own web app, your own video calling web app with your friends and get on video calls and maybe even do group calls, do let me know in the comments down below and I will create another video. But till then, thank you everyone. If you have any doubts, feel free to comment down below and I'll try to clear them out. And do go over the video as many times and try to understand everything that is happening. It could be a little confusing to understand the flow, but if you watch the video enough number of times and if you try to understand the code, it would be easy for you to keep track of it and fully understand the concept that WebRTC works on. So thank you everyone. Looking forward to your likes and comments on the video. Bye bye.